Hi again, everybody. Mr. Kolakowski here. I wanted to share a couple of other video clips that I have in my files with you all. The videos I want to share here are all related to wave interference, reflection, standing waves. Um, I've got some other stuff, but I thought this would be just a quick opportunity to share a couple of these files and give you some commentary. Let's go ahead and watch the first one. This one is called Wave Reflection at a Fixed Boundary. So in this particular clip, this apparatus that they built, uh, it's basically these wooden pegs sort of balanced here, and you can see that a wave pulse was just sent. What's interesting is you'll notice that the reflected wave is inverted. This is a fixed end reflection, and it gives you this inversion reflection. So that's a really cool way to see uh, fixed end reflection. Let's take a look over here. I've got a bunch of video clips. The next one I want to share with you guys is, let's see, let's go to this one. This is called wave superposition. All right, so I'm going to make this a little bit bigger. You know what? This is probably fine as is. Okay, we have two wave pulses, one sent from the left, one sent from the right, the red and the white wave pulse. The yellow is what you and I would see in the real world, okay? Um, I'll show you what that looks like in the real world in a few moments here, but the concept is that the red and the white wave, when they're at the same place at the same time, are going to interact with each other in this really weird way that waves interact with each other. Um, Here you can see that they've changed the amplitude of the white wave to be a little bit smaller than that of the red. Um, and again, when the two waves are at the same place at the same time, they add to create right there a superposition whereby the two waves add to one another in a constructive way. Um, here comes destructive interference. So if you pause the video right there, you'll see that the two waves being out of phase will destroy one another, creating a net zero result for the moment that the two waves are at the same place at the same time. Of course, after that interference, the two waves go their separate ways. Um, this is a really strange way of thinking about it, but imagine if you had two tennis balls coming at each other, and then for the moment that they're at the same place at the same time, they become a softball, and then after that instant, the two tennis balls go right on through each other. Um, of course, that's not how particles behave, but that is how waves behave. Sound, light, water, things like that. Okay, things that exist as waves. Okay. Um, all right, so that's wave superposition. Let me show you what happens in the real world. Let's go over here. Okay, so this is a constructive wave interference. We have, it's kind of hard to see this. You can see on the right-hand side a wave pulse is being sent from right to left, but we also have a wave pulse being sent from left to right. So here they come. Boom, right there you have constructive interference, and that's what knocks down the markers. Each wave independently doesn't have the amplitude to reach the markers, but together those amplitudes combine to knock down the two markers. Okay. Again, just to show that to you here, this is a slow motion video with an iPhone. Here comes the wave from the left and the wave from the right. They're going to meet up at the same place right there. And then the two waves progress in their independent ways, one to the right, one to the left, doing their own thing. This next video is a representation of how to create a standing wave. The first thing that you notice is that there's a progressive wave at the bottom of your screen. A progressive wave is just when you take wave pulses and you continually create that same wave pulse. Okay, imagine, um, for example, a vibrating guitar string. Okay, as somebody is playing a song. Okay, plucking the guitar string multiple times. What we have here is a fixed end reflection from a progressive wave. And what we would see, if you watch a guitar string, you can actually see it do this with a high-speed camera. What you'll see is that the reflected wave is interacting with the incident waves. And as a result, we know that waves interact with each other through superposition. You end up getting, in this context, a standing wave. At the top of the animation, you can see the incident wave is going from left to right, the reflected wave is going from right to left, and when you superimpose those, what you and I would see in real time is the standing wave. Um, I'll include a separate video of a guitar string that is undergoing a standing wave as a result of interference. Also, here we can see the nodes in red and the antinodes, which were the maximum displacements there in the standing wave. What else can I show you? This one's kind of fun. This is a longitudinal wave. Longitudinal waves, not to be confused with transverse waves, um, are where the particles that are the medium for which the wave propagates through, the medium, play that again here. This is like a sound wave, um, where you have the particle motion moving parallel to the propagation of the wave itself. This is what sound waves would look like if you could kind of visualize those in the air. My gosh, there's lots of cool stuff here. Last but not least, let me show you this. This is a couple of scientist guys, tell by their lab coats, right? Um, and what they're going to do here is this is a giant spring. They're going to try to create a series of standing waves for us. Okay, so the incident wave and the reflected waves are interacting with one another. You can see the the node here. We have a couple of more nodes, one, two, three, four in total. You can also see the antinodes, those maximum positions uh, of displacement. Okay, so I'll include some supplemental videos. I thought that would be a kind of an interesting way to make this topic a little more exciting and interesting. I hope you guys are doing okay with this material. Let me know if you have any questions about any of the topics that we've recently discussed. All right, everybody, take care. Talk to you soon.